This is 1.2 physical and versus chemical properties and 1.3 changes of matter. So here's a picture of a polar ice cap from outer space. If you look up close, you will see pictures like this and that one. So pause this image and try to answer the questions that I have shown you over here. What states of matter can you observe in these pictures? And how do these states transition from one to another? And finally, does the chemical composition of water change during these transitions of state? So the answers to the questions, for question 1, I see solid here. This is a giant ice sheet, right? A continent made with ice, and it's broken off into little pieces here. Due to global warming, the polar ice caps are melting. The sun's heat is getting trapped inside the earth, and the north and south poles are getting warmer and warmer. The thermal energy is causing this snow to melt and fall into pieces like this, and it's landed in the ocean in the liquid state, right? And do you see any gas state? Yes, we see some clouds over here and some clouds over there. So you see gas, water gas, vapor in there too. So how do these states transition? That's because they absorb energy from the sun, thermal energy, which is converted into kinetic or motion energy. When solid, the particles are moving very slowly. When you heat up, then the particles start moving much faster and you go into the liquid state. And then if you heat the liquid even more, they go into the gas state where you are so far apart and you spread out into clouds. So that's the answer to 2. Does the chemical composition of water change during solid, liquid, gas? No, it's still H2O. So when matter undergoes physical change, its chemical composition remains unchanged, and the distance between the particles is what changes due to changes in energy. So you should write that down. So throughout this lesson, in 1.2, you will learn to identify and describe the characteristics of transition states based on the energy particles gain or release. Explain how chemical reactions cause chemical changes to matter. And finally, compare and contrast chemical versus physical changes. Look at these 3 pictures. Which one has a chemical change? Yes, it is C. Something has caught fire and it's going to be changed irreversibly. At the end, you will have some black soot or coal or some charred stuff at the end, and there will be smoke. Whatever you burnt, you can't have it back. Now this is dry ice, solid carbon dioxide, becoming its gas state. There is no liquid state. It's called sublimation. And then here is some water boiling into this gas state, which is called steam. Both of these are reversible, and nothing happens to carbon dioxide or H2O in these 2. So here is a chemical change and here is a physical change. Look at this picture. We have some kebabs, right? And some they are in different stages of cooking. These are basically raw. These 2 are medium cooked. These are fully cooked. Is grilling a chemical reaction? Think about it. Can you reverse this? Support your claim whether it's a chemical or physical reaction with evidence from this photo. You can say, I think grilling is a blank reaction because I see this and that. Pause the video and make a claim. So grilling is a chemical change because it has changed the color of the kebabs on the left side. they have turned dark brown or golden brown, and they have some charring in here, and compared to the uncooked ones on the right. You could also say they lost some volume due to water turning into steam and evaporating, which is something that happens when you cook. And then this is the kind of claims you will learn how to make. So this is a chemical change, because you cannot have the raw kebabs again if you cool it down. Now I gave you this figure, you must paste it in your notebook. Matter can be divided into two types based on properties. Chemical properties describe how chemical substances react with another substance, or it breaks down or decomposes. Chemical changes are irreversible, and the original compound of matter undergoes change. Examples would be reaction with acids, oxygen or bases, flammability, and when some organic substance starts rotting. Now, physical properties physical changes are irreversible, and the original composition of the matter is unchanged. For example, melting point, boiling point, freezing point, electrical conductivity, luster, all of that are physical properties. They are reversible. These can be two types. There's extensive and intensive properties. Intensive properties have to do with your internal nature. Depends on what you are made out of. For example, no matter whether you have a big or a small piece, any kind of element or compound, the boiling point of them is going to be the same. Their color, shine, melting point, freezing point, compressibility and density are some of these properties that are never going to change no matter how much of something you have. On the other hand, extensive properties depend on how much of something you have, because mass, volume and length, for example, are properties that change with the amount of something you have. So next we are going to watch this video. It happens really quickly. This is a physical or a chemical change that occurs when you add heat. Did you see what happened? And then there's another one. So we saw the railway buckle because of the expansion of the atoms that make up the metal rail shown over here. So in hot climates or hot countries and hot weather, the atoms that make up the metal rails, they expand, they absorb thermal energy from the environment, and they start moving faster, and now they start expanding. If there isn't an expansion space big enough for them to expand, they start buckling like that, and you can have derailments. So when civil engineers make railways, they put a lot more space between the rails in countries where summers or the whole year is really, really hot. So this is an example of a physical change. And this is reversible. When the railroad cools down, it goes back to its original unbuckled state. So let's look at types of physical properties. And here's some vocabulary words. Phase or physical state is the state solid, liquid or gas. Ductility means can you stretch something into thin wires. Malleability means can you hammer something into different shapes like metals. You may have seen metalsmiths making horseshoes or swords or knives on TV in movies. Melting point is the temperature at which you become a liquid, and the boiling point is the temperature at which a liquid becomes a gas. And then electrical and thermal conductivity means does something conduct electricity goes through it, and does heat go through it. Solubility is the substance dissolving in another thing. For example, if you dissolve salt and water, you can extract the salt again by evaporating the water. Same with sugar. You can evaporate the water without heating it too much, then you will get back your sugar. Compressibility, this applies to gases because they're so far apart, you can squish them together. I need you to know that density is equal to mass divided by volume, and the unit so has both mass and volume units. So here's an example. Say I made a mixture with cocoa powder and water, and the total mass of this mixture is 60 grams or 60 g, and the total volume is 60 milliliters. So if I ask you to find the density, it's mass divided by volume. So you're going to divide 60 grams by 20 milliliters, and you get 3 grams per milliliter. So if you notice, that means the mass is always 3 times that of the volume, right? So if I have 3 times of this mass, then the volume will also go up 3 times. If I have 3 times less, the volume will also go 3 times less. So whichever amount of mass you have, the density will also decline or increase with that. So the ratio remains the same. This is why we say for a given substance, the density is a fixed amount. It does not depend on how much stuff you have. So it is an intensive property. You need to be able to calculate density. Let's look at physical properties. There are chemicals. Do you react with chemical substances like water, acids, bases, oxygen? Are you acidic or basic? It depends on the amount of hydrogen ions you have in the solution. We will learn more about this in acids and bases unit. Flammability, the tendency to catch fire. Toxicity is something poisonous. Typically, toxins are toxic because they react with molecules in your body. So that is a chemical reaction. Chemical stability. When you buy fish, meat, or any kind of canned goods or any type of food, there is an expiration date, right? That means after that day, things are going to decompose and not have the same freshness or taste. Some things might even become toxic. So this is called shelf life. And then heat of combustion again tie into flammability. It means the temperature at which something catches fire. So we are going to the next topic, physical states of matter and their transition states. Here we will learn to identify and draw models of physical states with different spaces between particles. Compare and contrast the states of matter based on volume, shape, compressibility, space between particles, temperature, and motion. Motion, again, as I said, is kinetic energy of particles. Finally, compare and contrast states, transition states based on absorbing or gaining or losing thermal energy. Please note that cutting, stretching, crumpling, breaking, dissolving, melting, freezing, evaporation, vaporization, boiling are all physical changes, because none of these things change the chemistry of the substance. So let's look at this picture. What state are these molecules in? Yes, they're in gas state. So what if you take away a lot of heat or freeze? Then they will come together and act like a solid. See, they are very structured, they are very close together. What if you heat this or melt it? Then they'll melt, and most of it hangs out in the bottom because of gravity. This is how you know this is a liquid. All the particles are close together, but they're in the bottom. There's no order. This is a solid because it has its own structure without hanging out with something else. And these guys are gas state because all the particles are spread out far apart all around the gas container. When you add heat to the liquid, you can get back the gas state. We call it boiling, right? So these are the physical state changes. Now, I gave you this figure. You need to paste this in your notes. So here are the transition states between solid and liquid. The transition state is melting. And when you heat the liquid some more, you turn into gas state, boiling and evaporation. If you cool a gas, if you are carbon dioxide, you will undergo deposition and certainly become solid. But if you have a gas and you gradually decrease the temperature, it condenses first and then it freezes into the solid state. So heating, you go to the left from solid to gas, and cooling, you go to the right from gas to solid. And the space in particles is increased in gas. In solid, the space is much more decreased. Now I want you to write this table down, and here are solid, liquid, gas state characteristics. So the shape of solids is definite, but for liquids and gas it's indefinite. So in gas, it takes the full breadth of the container. In liquid, it only takes a part of the shape of the container, depending on how much you have. Both of these, solid and liquid, have a definite volume, but gas is indefinite because it takes the shape of the container. They are so moving around, they just spread out through the entire container. When you look at motion or kinetic energy, solid has very slow vibrations, liquid has the second slowest one, but they slide past each other. Gas particles move rapidly in random motion with particles no longer attraction to each other. Compressibility, can you squish something? For solids, you can't really squish them. For liquids, it's weak too. For gases, you can easily squish them because they're so far apart. So here's the summary of 1.2 and 1.3 and the end of our lesson. We learn how chemical reactions cause chemical changes to matter, and we compared and contrasted chemical and physical changes. You can now identify and draw models of each physical state, solid, liquid, and gas. Compare and contrast states of matter based on volume, shape, compressibility, space between particles, temperature, and motion, which is also known as kinetic energy. Finally, you are able to compare transition states based on absorbing or gaining or losing thermal energy. I will see you in the next one.